Well, let's get started. Good afternoon or morning or evening, everybody, from wherever you're joining. Welcome to this webinar. My name is Ger Koole. Um, I'm actually one of the founders of CCmath and science lead. So together with a team of by now more than 10 people with a mathematical background, we do a lot of customer support. We also implement lots of algorithms, many technical things to make well to make everything work and in a good way. Today, I'm going to tell you something about forecasting and especially about redials. Okay, so let's get started. By the way, if you have any questions, there's a chat, so please put things in the chat. Um, and of course, if you have more elaborate questions that you would like to discuss in more detail with us, we're open to that. At the end, we'll give you our contact details in case you do not know. Of course, there are also lots of people here in the audience that we do know quite well, but probably also some new people. So please, you can put anything in the chat, and we're also happy to talk to you later if that is appropriate. Okay, so let's dive into it right away. So suppose this is your data. For simplicity, what you see here, you see at the x-axis, you see twice 1 to 12. So these are months. Be aware of the fact that months are usually not the good level at which to do forecasting. The number of working days in months, because weeks and months are not aligned, changes. So usually working at you can better work at a weekly level or at a daily level. So month level is not usually not the right thing, but just for the purpose of this webinar to avoid too many numbers in one figure, I took months. But be aware, as I just said, that that's not the case. So if you see this, the question becomes, well, what is your forecast? Yeah, so you have, for some reason, 1 year and 4 months of data, and now you have to make a forecast. Now, as there are many things that influence your volume, and one thing that is, well, I've never seen a call center without is an intra-year pattern. Yes. Okay. Now, there's also often a trend. So perhaps to represent it better, we do it this way. Yeah. So here you put the first year again in blue, and then in orange you put the first month of the second year on top of it. And then, of course, you see a pattern. Yeah. So it's when you see this, you think, hey, this is pretty obvious. This blue line, that is the intra-year pattern, a dip in the summer months, not that strange. We see that more often. We do see that the volume is a bit higher. It's actually, if you would do the calculation, around 5% higher. So probably a good forecast could be, let's assume that this 5% persists. And then the green line here would be a very reasonable forecast. Now, suppose that you wait for 8 months, or perhaps this is data, and if you're testing new forecasting methods, you're perhaps using what they call in AI methods, training and a test set. So perhaps you kept, this is perhaps 24, 25, and you hold back the last 8 months to test your methods. And now we're testing our methods. Yeah. And then what we see this, well, these lines, and I'm giving the full scale, but if you zoom in a bit, so perhaps it doesn't look that bad, but if you zoom in a bit, you can see that here around this months 5, 6, 7, perhaps, there's really a big deviation. Yeah. So instead of the second year being consistently above the first year, we see in the actuals, these are the orange one, the green one is the forecast, the orange one are the actuals for the second year. We see that this is lower. Now, what could be the case? of course, perhaps trend is changes, perhaps something happens. And to be clear, this is uh, this is synthetical data. Of course, this is based on our experience with lots of different call centers in which different things occurred. But to make things clear, I made up some data just to highlight the effects. Um, but this is something that could happen. Now, of course, there could be many reasons why there is this deviation. We have this error by the forecast, why the actual is not close to the forecast. Yeah. And so it's of course interesting in such a case to dive into this. Could be that there is an event, a trend change, competition, many things could happen. But well, the reason here is something else, and let's dive a bit closer into that by looking a bit better at the actuals. Because when we look here in these numbers, we do not just have, like in most situations, we do not just have the offered, which is the blue line, and here I plotted all 12 months. But what I did here, I'm also plotting two more lines. I'm plotting handled and abandoned. Yes? And if you plot, and then you see that there is this pretty big deviation here. Actually, and this is not such a strange thing. I've recently been analyzing data from a very different, as I said, this is synthetical data, but from an actual call center. And there's something like this was actually happening. So here we see that during these moments, in these months 5 and 6, actually there's a big difference between offered and handled. So there's a high number of abandonments. And why is that the case? Well, when do you have many abandonments? That's of course when people abandon, when waiting times get longer, and that's typically when service levels go down. So here in this data, what you see is that service level went considerably down during these periods, these spring months of this first year. And because service level went down, meaning waiting times, whatever way it's measured, actually these numbers are based on these call centers I was mentioning. So there you saw indeed that you had service levels as low as 15, 20% and abandonment percentages of 20, 25%. That can happen. While at moments that things went better, abandonment percentages were like 2, 3%, and service levels were in the 70s or low 80s. Yeah? So this really is a realistic situation, and so the question is, and perhaps you already realized the answer. So why is there a peak in offered? Yes, because this offered is higher and it didn't repeat here. Yes, and that is, of course, why things went wrong in our initial forecast. Yeah. So why is there a peak in offered here when at the same time abandonments were high? Yeah. And the reason for that is redials. Yes. So if people abandon, they call again, and offered includes also these redials. So what you typically see is that abandonments, some people redial, and that leads to a higher, to relatively high numbers of offered. Yes. And because we were initially looking at offered, yes, when we made our forecast, we kind of projected these these redials on the future. And then in these later months, our service level was good. So as you can see here, and so these redials didn't occur. Yes, and so we projected redials on the future while these redials didn't occur. So How could you avoid this? Yeah, how could you redo your calculations to to kind of filter out the readouts? So then you need, well, somehow the logic of how these readouts work. Yes, and the logic of readouts is here in this in this figure. Yes, so what you see here, and you see, of course, things that are familiar. You see O for offered, you see H for handled, you see A for abandoned. Yeah, and of course, if service level is bad, if waiting times here in the queues are long, yes, you have many abandonments, or the small a, the abandonment percentage is relatively high. So here you see, just to go through the full logic of this diagram, you have fresh calls, customer requests coming from, well, from the outside of the system, people entering your call center, they enter the queue. Then here, this circle represents the agents. Yes, this is like, well, standard way of drawing queues. Also for, if you would see a diagram of Erlang, you typically would see something like this. So, of course, when you reach an agent, the call is being handled. What I left out here is that you might get, even when a call is handled, if it's not handled the right way, if it's not a first time fix, or whatever way you want to call it, might be that you get a redial or recall or reconnect, as we sometimes call it. Here again, I left that out. But if the call is connected to an agent, of course it's handled when the call is finished. But you have here the abandonments. Out of these abandonments, a certain fraction, and we assume that a fraction is fixed, a fraction calls back. So the offered is like, let's say, polluted by these readouts. And when the service level is bad, of course, this abandonment fraction and the number of abandonments is high. They're relatively high fraction going in again, and that increases the offered amount. Okay, so however, we do not know F, the amount of fresh calls. What we typically do know is offered, abandoned, and handled. Yes, so let's do the mathematics. So the number of abandoned calls is the fraction of abandonments times offered. Yes, that makes sense, right? So that is the fraction, and this abandonment fraction, small a, typically depends on the service level. For example, Erlang X could be used for that if you want to estimate that. Now you see what is fresh. Well, it's of course, or you could say this way, offered is fresh plus what comes from the abandonments. And what comes from the abandonments is the number of abandonments times this fraction. Yes. So fresh is offered minus what comes in through here. So that is offered minus P, this fraction, times A. And as I said, we assume, and that's also what data analysis shows. I'll come to talk about that. But it's usually close to a fixed fraction. Yeah, and this A, that is, of course, as I said here, small a, had a fraction of abandonments times offered. Yeah, so this is a formula for the fresh numbers. Yeah, and if you do the mathematics, you see here O minus PAO. If you remember a bit of manipulating these type of formulas from mathematics, you can of course take this 1 times O minus PA times O. You can take the 1 times PA out of it here and then divide on both sides. Then you get offered. Here is fresh divided by 1 minus PA. Now the small a is different from day to day. Again, it typically depends on the service level. And because you know offered and abandoned. And you can easily calculate this small a. That's not a problem. But the problem here is, how do I determine this redial fraction? Yes, how many of my abandoned calls are going to redial? Because if nobody calls back, if small p is 0, yes, and everybody who abandons is also lost, yes, then then of course fresh is equal to O. But of course, if everybody redials, then there's a considerable number of offered. That is actually, that consists of redials. Yeah, so it depends on this small p. So it's important to determine this small p. By the way, it's also important to realize, and we did also as a couple of years ago on the number of call centers analysis. What happens is that people call back relatively quickly. Here we're looking at a month level. Of course, people call back within the month, but many people call back actually within the same hour, or at least within the same day. So if people call back, they usually do so relatively quickly. And there's also a bit of a definition question. If people call again a week later, is that for the same issue or a different issue? But if you look at the statistics, you see that abandoned calls, when people who abandoned, when they call back, that is relatively quick. So again, how to determine P? Well, one way is diving into the data. Yes. So if you have call by call data, then probably you have, for the majority of your customers, all the calling numbers. So you have their IDs, and you can look at, you can do the data analysis, you can dive into the numbers. Of course, that requires, have some time, perhaps an analyst to do the data analysis. And so that is some work. I do think it's interesting to do, at least do it once, try it out, or have a data scientist and do it every week or every month to make a regular report out of it. If you say, I don't want to do that, but I want to do a better job than just focusing on offered, actually what you could do is just take an average value. And we know it's somewhere between 0 and 100%. So whatever the value is, say I call it a low risk guess, let's put it at 50%. Yeah, you can never be wrong by 50% in that case. So it's always better than taking it into account. If you're doing just offered, that's like kind of assuming that nobody calls back. Yeah, if you think, hey, my offered is actually my fresh, like I did in the beginning when I completely ignored it. So setting P equal to 50% is already better than not doing it at all. Okay, so that is the logic behind it. And of course, you need little data. Definitely, if you take this P is equal to 50%, then it's easy. And of course, you need abandoned and handled, but usually you have that. Okay, so if you've done this, what are the next steps? Well, so the first thing, so if you now do forecasting, but now you're taking redials into account, of course, the first step is that you filter out the redials, yes, by having an estimate for this number P. And again, it could be 50%, by knowing next to offered abandoned, and then of course you also know handled. Yeah. Then the second step is forecasting the fresh volume. So that is like not, so that is without the redials, you forecast the fresh volume. And the idea is that these forecasts, of course, because you have less effects, these redials to take into account, that is also an easier job than when you have them in. Then the third step, you can do two things. Yes, you can say, okay, it's actually the fresh I'm interested in. Yes, so I don't want to work with offered anymore. I will work with fresh all the time. Yes, you could use, and during other webinars, and I've been talking about that, so many of you will be familiar with the ideas about it. But Erlang X or is the way actually to extend the existing Erlang formulas with redials. That's what is the difference. You have Erlang C, no abandonments. You have Erlang A, is Erlang C with abandonments. And you have Erlang X, that is Erlang A with abandonments and redials. So if you put this and this p-value, you can actually enter it in the Erlang X. So if you work with Erlang X with redials, if you put that higher than 0, that's actually that is actually suitable if you work with the fresh volume. If you work right away with offered volume, the redials are already in the offered. So in the Erlang X, you should set redials to 0. So either you continue working with the fresh volume, or, and that's the second option, you go back to working with the offered, but you add a reasonable redial percentage, because you're going to have an 80% service level and perhaps 3% abandonments with that. So you can add the abandonments using the formulas I showed you. You can add that again to the to your forecast, and then you have a forecast for your offered, but with the right number of redials in it, and not like I did in the very beginning with too many redials in it, because that's actually what happened. You projected the bad service level with the many redials on the future, and then hopefully in the future you're doing a better job having less redials. Okay. And then, of course, what is always a good thing to do, what we do not always do, but what we should do in a systematic way, is validate using actuals. And again, sometimes you do this, like I use the example, we have data up until April. So you're waiting for the data of May, and then you're looking, okay, how am I doing? And perhaps adapting your methodology on the basis of that. If you want to evaluate your forecast, yes, then you should, of course, work with historical data, and then hold out some of your data and test your methods on the data that you kept out, and see on the basis of the outcomes for that data how you can improve. Yeah? Okay, and that is actually what I want to show you next. So let's move on with this. And we're actually going pretty fast. But I hope that you understand the concept behind it, and this can really help you, especially if you have such a period with lots of abandonments and a bad service level, that can really filter out the effects of that. So what do we have here? Here are all the lines together. So let me slowly walk you through everything. So the first line is the offered volume. And again, this was this, I think it's dark green. It's hard to see the color, but it's the top line here. With this deviation here, that was the line. And as we saw, this line could be explained by a high number of abandoned calls. And what you do, that was the formula. You take this offered line and you subtract this P minus the abandoned to get your estimation of your fresh volume. So that is this light blue line here up until here. So that is the first step, filtering out your filtering out the readouts. Then the second step is forecasting of this fresh volume. Now here I made things super simple. So we had this increase on average of 5%, and we project the same intra-year pattern on the future. Yeah. Of course, in reality, hopefully you have more years of data. There are more effects that influence your volume. So of course, the intra-year pattern won't repeat itself exactly as you can see it here. Again, this is an illustration, and I filtered out other effects to make this effect really clear. But the light blue line is the estimation of your fresh volume, this combination of trend, 5% more, intra-year volume with the dip in the summer, gives you the projection. And here are a couple of lines on top of each other, so they are a bit harder to identify. But one of the lines here is a red line. So that is your forecast of your fresh volume. Okay, now we're going to step 3. And then we have 2 options. Either you continue working with your fresh volume, or you add again your offered your redials to it. So suppose that you expect you have the workforce to have a good service level, so you expect 3% abandonments. Out of these, let's say half will redial. So here you add this 1.5% redials to this offered volume. So that is the purple line that is just above the red line. And then the last step, again, you should definitely, that's basically the reporting, but it's not just reporting to how things went to management. It's also the feedback loop that tells you, how did I do? What can I improve? What went well? What went wrong? That allows you to improve your method. And here, of course, as I said, I made these numbers up, so it looks really nice. But here you test it, and then you get this green line, which was this, and that testing is either based on a separate test set, or perhaps you see it when time over time, when you get the actual during the year, and then you can see whether you did a good job or not. Okay, so what is the goal of all this? The goal of all this is, of course, to get a more accurate forecast. And I'll get to the answer. So I see a question coming in, but I'll get to that. So as I said, this example is based on synthetic data, but I also want to make it clear. I've been analyzing data myself, and as an organization, we have lots of data. Some customers have really pretty regular service levels, so they experience regular amounts of abandonments. Then this might be less of an issue, and it's perhaps not worthwhile diving into the details, especially if you have certain prolonged periods with that service level, which for whatever reason can happen. And this can really be helpful. So this is especially relevant in cases with fluctuating service levels, high abandonment rate. And what I also like about it, and nowadays when we're talking about AI and people are using black box algorithms, what I like about it is that we understand what's happening. Yes, and it adds to our understanding of the call center if we determine something like this this redial fraction, or if we and we see what how we can repair for that. So I think it's also as an understanding. I think this is interesting. Yes, and indeed, some of our customers are helped by making this difference. Again, it helps them understand their call center a bit better, but it also helps in improving the forecast accuracy. Okay, we're a bit earlier than other times, but I think I really wanted to talk about this because I think this is a conceptually interesting thing, and it also for ourselves, it took us a bit of time to really understand this and how this works. And it adds up nicely. If you're using Erlang X, it goes well together. with Erlang X. Conceptually, these things go together. So, and actually, next subject for our next webinar, which will be, by the way, I think that will be after the summer. And we will talk more about Erlang X, for which we recently released a new version. So, or recently, we have the new version ready, but the release will be somewhere in 1 or 2 months, and then after the summer, we'll explain to you what has changed and how we improved it. Okay. Thanks. To round up, if you think, I'll come to the questions later, but thank you for your thoughts, and we'll get to that. Just as a roundup, if you think, hey, this might be interesting for our data, please do contact us if you're interested in our forecasting tooling. If you would like to see, hey, what difference would it make if we make this difference? And if you would even go a step further and think, hey, what would this mean if I increase my accuracy? What would this mean for my operation, perhaps also from a cost point of view? Because the consequences of having a better forecast, well, they go a long way in the sense when you think about customer retention and employee satisfaction, etc., etc. Actually, there are a lot of indirect benefits of having a good forecast. And you can always contact us. You can contact me or Wout or our CEO, who also does much of the talking to our customers. If you want to know more about these things, we do organize training. Actually, yesterday we finished a forecasting training, but there are more. We regularly give trainings on all kinds of subjects, on forecasting, on Erlang, on multi-scale issue, multi-channel issue, blending. We do them. We have e-learnings. We do them online, face-to-face. If you have a group of people, we could even come to your location. We're happy to do that. If you want to know more about trainings, Jesper is in the call. Please talk to him or talk to me directly. We do give a lot of trainings, and I think one of the most, what we stand out is, of course, our knowledge of the mathematics, of forecasting in Erlang and everything. We put that in our trainings. We also put that in our software. So if you're interested in having a look at our software, if you want to have a look at our software, do go talk with Wout. He regularly gives demos, but I'll be happy to talk about our tooling and our algorithms as well. That's it for now. And let me have a look at the questions. I see a couple of things that people said. If you want to leave, I completely understand it. But I see one easy question coming in, the last one. All our webinars are on our website, including the slides, including the recording. So if you're interested in other subjects, please go to our website, have a look at the webinars that are there. If you want to talk further, do please contact us. I'll go through the questions. John, as redials occur, queues grow. Yes, which in turn increases the average speed of answer. Yeah, I'm talking about service level, but could as well have plotted the average speed of answer, which further increases the abandonment rates. Yes, if you have a bad service level, so redials themselves. Yes, there is. Well, actually, this is, this self-propelled effect is part of the Erlang X, and that is what differentiates Erlang X from other tooling. So if in Erlang X, if you enter fresh volume, this self-propelling effect, as you say it, that's a nice term. That is part of the Erlang X. So Erlang X will tell you, okay, if this happens, This is, and it will give you an estimation of your offered based on the fresh volume. So that is like the first option in three. It's not part of the forecasting. It's part of the Erlang staffing. Yeah. So that's what's happening there. But definitely the self-propelling effect, that is crucial if you have high abandonment rates. And therefore we invented Erlang X. Yes, not related. Yeah. The year to year, year on tops of each other is very useful to analyze. Okay. I think a good question. Is it perhaps on the roadmap? I should ask this question, Pierre. Thanks for
Lequel?
asking this question.
Ben, je l'avais vu pas loin, mais je sais plus, depuis, je sais pas, il a dû être rangé.
Indeed, I know there are certain things on the roadmap. I will ask Giuseppe to tell you if there are any plans and if we can do that. But thanks for the question, Pierre. Synthetic data I've recently used. Okay, that's interesting, Philip. Yeah. Well, so to answer, Philip says synthetic data is very representative. Real data set are recently used. That's very good to hear. I use the 50% or something similar rule, which feels pretty crude, but this choice has small impact when you embed. Yes. So here, in what I showed, of course, if you expect in the future a bad service level, you should, and you're working with offered, of course, you should use higher percentages. The way I presented it today is that it filters out, it avoids you having the wrong impression from your historical data. And so that's how I used it. So it's it's something that won't repeat if you go back to good service levels. So it's a way of what they call overfitting in AI, is that you project something from the past on the future that won't occur actually. Yes, so that is what's happening. So it's actually, you use it to better understand your history and to be able to better make a forecast, because the most important thing is about forecasting is really understanding the history. Yes. Doug, good to see you. How do you determine the readout fractions? Yes, so that's a good question. Actually, if you have multiple years and you have, let's say, 1 year of a bad with bad service level, you might say, oh, the difference between other years and that year is this p-value. So actually, statistically, next, you have lots of variables about your intraday and your inter-year variability, and you could even, statistically speaking, get an estimate of this p-value. Yeah, but that is not easy. If you have a nice use case, I'd be really interested in diving into that. That's an interesting question. But as Philip just said, if you have no clue, then the low risk answer is 50%. Yes, and with forecasting, there's always the question: how deep do I dive into all these numbers? There are lots of things that where you make errors, where you're not so sure about the values because you have limited data, because all kinds of things happen, some of which you do know, some of which you didn't know. So how far should I go into, really, going into a lot of detail about certain things while make bigger errors in other things? Yeah, so as a first guess, 50%, I think you're already good. Any tip from monthly? Ooh. Well, there's a question, of course, and not directly related to here, but related to the fact that I showed you monthly data. Again, try to avoid. So I hardly ever get monthly data. Usually you have daily data or perhaps weekly data, and then you aggregate to months. Yes. But I understand your question. Suppose for some reason it was aggregated at the monthly level. Yeah, then I would say look at typically if a call center is open during the weekends, volumes are often lower than during weekdays. Well, if you have some indication if that is the case, look at the number of working days in a month, perhaps also exclude holidays when the call center was closed, and then kind of try to come up with, divide the monthly volume by the number of working days, then you have the volume per working day. Yeah, and then you can start working with that and see if that makes sense if you have multiple years of data. Kazi, that would be my advice to you. But these are typically these ad hoc cases you have to dive in one by one. Okay, these were the questions for now. So thank you very much for attending. I hope this was, again, a useful webinar. And again, if you have any questions or want to have a further discussion with us, no need to, please do contact us. We will record, the recording will be online in a couple of days. You will get an email, and of course you will get an announcement of further mail webinars and blogs that are upcoming. It's always fun to do these webinars. So thanks again for attending, and hope to see you soon. Bye-bye.